Okay, so good evening again, everyone. Today we'll be looking at the Python programming language, its applications, and hopefully in the near future we'll be able to discuss the usage of Python for artificial intelligence. So, for those who don't know, this is a quick rundown of Python. We'll get into the programming aspects of it shortly. Well, this is just a quick rundown of Python. Again, since we're recording, I don't want to go too long, so we might not get to complete everything now. However, if not, we could always host another session, or I'll just go ahead and pre-record, upload to YouTube, and then provide the link with various resources. So Python, as it says here, the programming language that can be used for web development, software development, mathematics, and system scripting. And additionally, it can be used for artificial intelligence. So when working with programming languages in general, not just Python, sorry about that. We typically use comments to ignore code, or we can say we use comments for user information. So let's say, for example, you were writing some code, or you're learning something new. You would use a comment to, comment it out, or to have the Python interpreter ignore it. And then once that is done, the interpreter won't execute the piece of code. It's only there for your purpose or for your insight. And to create a comment in Python, we use the hashtag or the pound symbol. For those of you who may be using Visual Studio Code, you can go ahead. Let's highlight whatever it is and then use Control question mark. And you'll get to highlight everything and create a comment. So comment and uncomment. So let's say, for example, and don't worry if you don't understand what's happening right here, I'll go over that shortly. So let's say, let's just do this as a matter of fact. So let's ignore all of that and I'll zoom in. Can you see the screen a bit better now? Someone can just confirm.
Yeah.
Okay, great. Just speak with me throughout the video, throughout the recording, so I can know exactly what's happening. Okay, so yeah, let's say, for example, I run this. As a matter of fact, let's not do this. Let's comment this out for now. Let's say I run this. It should print out this string of text right here via this print function down here. So let me just show that. And I press run. It should return this value, which is being shown right here. However, let's say I comment that out. Well, nothing is going to happen because there is no x. So I wouldn't be able to print anything because the variable x now doesn't exist. It's completely gone. Python is ignoring it. Hence this little yellow squiggly line coming up. And if I try to run it, it will spit an error at me. X is not defined. So that's just a quick example of how comments work in Python. Now, next up, you see me doing something here and in this print statement. And let me just break it down. Let me just comment this out and then break down this. So let's say I have print x. What this x is doing, or this print statement is doing for the variable x. And don't worry, as I we'll get into all of this later in more detail as it relates to variables. But I just want to explain to you what this type method or this type function is doing right here. This print x is simply accessing the variable and printing out the value of the variable. So wherever x is, it's storing this value. So instead of printing that value, let's say I wanted to print what data type x was. And you can use this whenever you're debugging your code really. The applications may not be so obvious right now, but let's say you're doing something a bit more complex later on, then this may come in handy. So to find out the data type of what you're doing, you simply use the type function. And we do that by saying type, open and close brackets. And then if we were to now print out this, it would return the type, which in this case is a string and not the actual value of the variable. So if I execute this, I bring on my terminal, it says the type is of string. Is everyone following with me so far?
Yes, sir.
Yes.
All right, good. So I can just go ahead and remove all of that for now. All right. So now to this, and let's go all the way up here. So this is a bit lengthy. However, I don't think it should take us too much time to figure out. So let's say you were to store, or you want to store a value. How would you do that? You would do that by using a variable. And a variable is simply a container for storing a value. You can think of it as a box, or even a cup, or even a glass. So you have a glass, which would be the container, and then you pour some water in that glass. The glass will now hold the value, which would be the water in this case. However, it's the same thing with programming. You want to store some data, you would store them in what is known as a variable. Now, typically, variables should be meaningful, meaning that you wouldn't name, or you wouldn't have someone's last name stored in a variable called first name, right? You typically name your variables according to what they store, so that you can easily pick up when you're reading through your code what exactly you are doing or what exactly the variable is storing. And here I just have some examples of different variables storing different values. So I have x and I'm setting that to 5, or I'm assigning the value of 5 to it using the equal sign, with the single equal sign. And I emphasize single because we'll be looking a bit more on operators later on, and then you'll see exactly why I emphasize x, the single equal sign. So here we have x being set to 5, y being set to John, and then I'm printing x and printing y. So could someone just simply tell me what they think would happen if I were to actually run this and print x and y?
It's going to print 5 and John.
All right, that's correct. Okay, cool. So again, in Python, we have different data types, and we can implicitly state what data type a value should be. And don't worry, we'll get to the different data types later on. I'm just giving a general overview now. So introduce the concept so that when we actually go into it, you'll know exactly what I'm referring to. So for now, let's say we have the variable x and we're storing 3. As a matter of fact, let me just comment this out. I'll go over here and let's see, I can do this. Let's do that. Let's uncomment these. Go here. Come here. So let's say, for example, let's remove this. Let's remove all of this and that. Here we have x being set to 3. 3 in this case would be of type integer. And we know that integers are the set of negative or positive whole numbers. So in this case, x would be an integer. If we print x, it would return the value of 3. If we print the type for x, it would return value int or integer. However, if we were to type cast x, meaning implicitly changing the value, or the data type of what x is, we would do so by saying, and let's say in this instance, we want to change x, or the 3 that is being assigned to the variable x, from an integer to a string. We would do so by saying str for string and surround the value in open and closing brackets or indices. And then if we run this, it should print out class or type string, because now we're implicitly changing the value of the 3 from an integer to a string. Everyone understand what I said? Yes, no, maybe so.
Yes, sir. Understand.
All right, cool. So that's just an example of why we use casting. Again, you'll see more practical examples later on, but for now, this is just, as I said, a short run through for when we get into the meat of the matter. So you can think about it as let's say, for example, you're studying or you want to catch up on a class, you do some reading up on your own without fully understanding it, and then going into the class and having your teacher explain it, like, oh, I read that, so I know I've seen it before. So I'm just putting the information out there to you so that when we formally get into it, you're like, oh yeah, I've seen that before. I have an idea of how it works. Let me now apply the knowledge and test it out for myself. So as it comes on to variables in Python, variables are case sensitive, meaning a lowercase a and an uppercase a are not the same thing, right? Even though it's the same a, the name of the variable is totally different because it's in a different case. So let me even just, let's just copy over to the other file. Let's come here, comment this out, comment that out, come here, remove that, and then if I print, and then I print again, then I do this, Control F5, we see 4 and Sally. Or let's do this. Let's come here and do the same thing here. Should be there. Let's make this capital, right? Value of the second is And let's run that. It prints the value of the this is bad. Yeah. So it prints out the value of the first variable, variable, spelling errors, but that's a base. B L E U. So the value of the first variable is 4 and the value of the second variable is solid. Now for those who are observant, let me just ask you one quick question. Why do you think I had to print? And let me see if that's a raise hand. Yeah, I realize, but I'm just ignoring it. I realize. So why do you think I put this string of text here in quotations and then I had the variable outside of the quotations and then separated it by a comma?
To
Can
separate
anyone,
the,
could you repeat that?
to separate the variable, sir. If it was in the quotation, would be printed as just the A itself.
All right, yeah, but why exactly?
So
You're on the right
you can
path.
change
It
the
indicates
variable.
Because what?
So you can change the variable.
Well, that as well.
So
But
is it because it's a string
all right, so
and you have quotations, double quotations?
all right, yeah, so that's what I was looking for. So typically, when we're printing or accessing variables, well, no, let's stick to printing. So when we're printing stuff to the console or the terminal, anything that is inside, and this is for Python, anything that's inside the double quotes or single quotes, because you could use single quotes, but we'll get to that shortly, is read as a string, right? A character, a collection of characters, which is a string. So Python views this as text to be printed. However, the variable on the other hand actually has a value here that we want to access. So if we were to then take this and then put it here, it would print the value of the first variable is a and then 4. And then let's do the same thing for this as well. So let's copy it, and boom. So anything that's inside the quotations will be read as a string. But once we put it outside and then separate it with a comma, Python will then go ahead and access the value of it because it's now being read as a variable. Understood? Hello?
Yeah.
Yes, sir. I understand.
All right, cool. So that's typically how you would access the variable. Let's remove this and remove that as well. And then also you can reassign variables. So you have A being set to 4 and then set it to 5. Then what will happen is that in this line 14 here, it will set A to 4, and then in line 15, it will then reassign value to 5. So if I do a print statement here, if I print A here, and then I do the same thing down here, I'll just comment this out, and I run this, it will print 5 as shown right here. It prints out 5. However, let's say I uncomment this. Oops, my bad. It will print 4 because the value has been initialized to 4 at first. Then when it gets to this line, it's going to reinitialize it or reassign the value to 5 and then print it out as 5. So this should print 4, and this should print 5. To demonstrate that, let's run it, and we see 4 and then 5. Alright. So this goes back to what I was saying earlier. Variables and in how you name your variables and letting them be descriptive. Now, when it comes on to naming your variables, there are also a few special rules that we must adhere to. For example, the variable name must start with the letter or underscore character. The variable name cannot, in no case, start with a number. If you do that, it will be wrong. So let's say 1a, it's red, right? It will not allow us to do that. We print 1a, print 1a. You see, if we try to do this, it will spit an error at us, or it will throw an error. So we're already seeing that we're having problems, and it says invalid decimal letter. So again, don't try to name your variables beginning with new numbers. And variable names can only contain alphanumeric characters and underscores. So that's pretty self-explanatory. I don't think I need to go over that one. All right. So let's say, for example, you have a variable that has multiple words in it. For example, first name, which are 2 different words. You have different techniques that can be used to write, or there are different techniques that you can use to display your variable names. One of them is camel case. That's where the first letter, the first letter of the variable, excluding the first part of it, if that makes sense, is common. So the first part is all common letters, and then the first letter of the second part is capital, and following on for the third part, because we cannot have any spaces within our variable names. So boom, this is my variable name, but we cannot do this with spaces, so we say we go like that and like that. The next way is to do something called Pascal case, where the first letter of every word is common, as we have here. And then finally, we have snake case, which is the preferred standard for Python, where we simply use underscores to separate variable names. So even if we're going to use something like snake case, we could still make this uppercase, right? However, we don't have to, since we already have the underscores there. So yeah, in Python, or whenever we're working with Python, it's typically associated with using snake case as the best practice, or as the defined standard. All right. So is everyone following so far? Any hiccups, any misunderstandings, anything? Should I go faster? Should I continue at this pace? Provide your feedback and let me know what to do.
You can continue at this pace.
All right. Anyone else?
You can continue.
Okay, cool. So next up, let's say, for example, we want to assign multiple values to a variable in one line. And before I even speak on that, I was talking earlier about assigning values to variables. In doing so, what we're actually doing is initializing a variable. And what I mean by that is simply saying that I am actually adding a value to a variable. So I can say, typically in programming, you can either you can declare a variable and then initialize it. However, in Python, you typically just go ahead and initialize due to the way Python works. But I'll show you a slight workaround in some sense. It's still initializing it because you're still giving it a value. However, you're not explicitly giving it um an actual value. You're assigning a data type to it in some sense. So I'll show you what I mean shortly. So let's say you have a. A by itself is nothing. We use the equal sign and then we say 5. So in this line, I'm saying 5, or the value 5 has been assigned to the variable a, and that would be called initialization. Initialization. So let's say you didn't actually want to initialize a variable or actually give it a value. What you could do is just set it equal to a data type. And to do that, we'll still be using the a variable. Let's just say a equals int, and leave it like that. So a now doesn't actually have a value. Like up here, it's just been set to the data type of integer. Whereas here, we're actually initializing a with the value of 5. So 5 will be stored towards or in a, whereas here, we only have a being set to an integer, but it doesn't actually have any value. Is that clear?
Yes, sir, but how does A get a value now?
By doing that. Or you do that.
So if I did want more to it, like add something add 1 to it or so forth.
Meaning yeah, have 9
A
plus 1.
equal the integer bracket plus something. So basically A would be the integer, you'd get it like the gonna say enter number. And when you enter the number, program supposed to get like the sum of two numbers or something like that.
Alright, so we'll look at
So
that
you don't
shortly
want
when we get to accepting user input, and that's coming. See how far the code. So after data types, then we'll go to user input. So don't worry, we'll be doing that quite shortly. I'll definitely look at that. But I was just showing this way, because as I said, the aim is, let's say, suppose you want to go on to another programming language where you can initialize, you can declare a value and then initialize it later if you so choose. I'm just showing you that, hey, it's possible. Even though in Python, you typically initialize right off the bat. Right, so that's the whole reason why I did this right here. But I'll definitely get to what you're saying when we look at accepting user input. Alright, just comment this out. Move on. And in here we just have accessing, or we're assigning values to multiple variables in one line. So we have the variables x, y, and z, and then we're setting it equal to orange, banana, and cherry, and then we're printing out x, y, and z. The reason why it works is because, again, we're using commas, and we have the three variables here and then 3 values here. So they will be assigned in order of the variable or the value. So come here. It should print orange, banana, and cherry in this order. And the only way it would change is if we, let's say, sent y over here, then y would be equal whatever the first value is. Run it, and you see orange, banana, and cherry. And then we can also have the same value to multiple variables by only assigning one value. So we say x is equal to y is equal to z, and z is then in turn equals to orange. So we just use the assignment operator, which is the equal sign, to take care of all of that for us. So if we print this out, it should print one value, which is orange. We have some stuff down here, but I don't want to go into this right now. We could come back to it later because we'd have to look at list first. So that's typically everything. Let me just turn this off. All right, so that's typically everything you would have to do or have to know when it comes on two variables as it relates to Python. So let's move this and zoom out a bit to where this is big enough to see. Great. So as we were looking on earlier, we discussed that Python has quite a number of data types. Some of them you will definitely use more than others. However, I just included all of them for reference. So the first data type we have, or we saw, is a string, which is simply a collection of characters, or you can simply refer to it as a text or as a text value. Then we have numeric data types, which are int, shortened for integer, floats, which are decimal numbers, or as they are called, floating point numbers. And then we have complex numbers, which are used in higher level mathematics. We won't be necessarily looking at them as much because they aren't as integral to what we will be doing. Well, it's okay to know that, hey, they exist. Then we have sequence types, which are list, tuples, and range. Mapping types, such as dictionary. Then we have set types, such as sets, frozen sets, Boolean types, which can either be true or false, binary types, and non-types, as depicted right here. It's more back. Yeah. And then down here, I have just a few examples of the different data types that we have mentioned. So the first one is a string. You can see the second is an integer. Then we have the float, which is the decimal number. The complex, which consists of the real number 1 and the imaginary number j. The list, the tuple, range, the dictionary, the set, and so on and so on. Then I simply just have some explanation going on here for the different data types. So I'll just move through this quickly. And as I said earlier, if anyone has any issues or anything that they want to know, then go ahead and ask. So learning moment for everyone. So a string is a collection of text surrounded by double or single quotes, and here we have x is equal to str in double quotes, and we could even set it to single quotes and it would print out the string when we try to get the type of x using the type function that I showed earlier. Then we have int, which is short for integer, whole number, either negative or positive, without decimals of unlimited length. So it can either be a positive number, or a negative number. And we can just print out the type here, which would return integer. Floats, which are decimal numbers, can either be positive or negative, containing one or more decimal. And we just have a few examples right here, and then we're printing out the type. If also, I don't think I mentioned it earlier, but I will be giving out this entire repository. I'll be sharing the link to it Still working on a few stuff. I want to update it some more and add some information to it. But what I'll do is just I'll give out the link, and then as I go along and edit, I'll push the changes so that you can see the changes in real time once new information is added to it, so that you can go ahead and review stuff on your own. But just be a bit patient with me. So complex numbers, which I said earlier, they have a real part and an imaginary part. The real part in this case, 3, 5, we're simply adding that 5, 8, and then we have the imaginary part, which is j. Now, again, we won't necessarily be looking at complex numbers, but it's nice to know that they exist, hence why I presented them here. Then we have type conversion. And type conversion is a bit similar to casting, which we did earlier, where I showed you how to declare a value in some sense, or when I was showing casting. So in this example, we have x being equal to 1, y being equal to 2.8, and z is equal to 1j. Then we want to convert a from an integer value, which is 1, to now a floating. Well, we're converting x. So let me just show you how this is done. Let me just grab all of this. Get over to here. Comment that out. And then come here. So this should, where's my mouse? Should make sense. So here we have the value x. Now we're setting it to 1. Then we're simply creating a new variable called a. And inside of this variable a, we're casting whatever x was earlier to a floating point number. So in this example, x was an integer, and then we're now casting it to a floating point number or a decimal number, and then setting that value to a. So if I print a, it should print out 1.0, and if I print type of a, it should print out float. So let me just, no, I don't need to change those. It should print 1.0, 0, and this should print float. Let me just try to get my floating point number. So run this. It says 1.0, and it prints out class of float, exactly as I said right here. Everyone, can you see that properly? Understand what I just did?
Yes.
Yes, sir.
All right, great. So that's just a quick example of how we'll be using, or how type conversion can be used. But again, we'll do practical examples later on, especially when we get to statements and so on. So yeah, that's typically everything you would need to know as it relates to different data types in Python. But for now, let us move on to what we've been waiting for. So we've seen how, oops, my bad. All right. So we've seen how we can get the user to define a variable by initializing it, right? And That's by doing it manually, where you have a variable and then you set a value to it. But let's say you want, as a matter of fact, let's ignore all of that. Let's come down here. Let's say you want to ask a user for a value. How you do that is by using an input function to prompt the user for a value. So let's say we have a variable called x. Matter of fact, let's call it name because our variables should be descriptive. We say name is equal to input curly parentheses, and whatever we have in our parentheses, we'll surround it with double quotes because it's a string. String is a collection of characters or simply text. And let's say, please enter your name. Let's do semicolon here in some space. So if we run this, we now have the option to enter a name. So see it here. And there we have it. We've just asked our user for their name. So whatever value the user types in here will be stored within this name variable. And they can also input a number. Let's show you. It doesn't have to be a string. They could say 1 and press enter. So they can enter really and truly anything they feel like. However, we can use type conversion or casting to set whatever they enter to what we want it to be casted to. And I'll be showing you how to do that shortly. So let's say, for example, we have this name variable. Let me just delete this. I want someone to tell me, you can just unmute your mic. I want someone to tell me, how can I ask a user for their first name and then print out the value of the first name? So I'm asking the user for their first name and then print their first name. Then just go ahead, open your mic and walk me through how I would do that.
Sir,
Yeah, go ahead.
you make the variable for name first. You initialize name, but you're not gonna put anything in the brackets. So I
All right.
say
So,
first name
I'd say
equal
first, hold on, underscore name
yeah,
equal. Mm-hmm.
parentheses, I think you call it.
Mm-hmm.
With this circle. Alright, cool. Now you gotta go down in the next line now. And you gotta say you enter your first name.
So hold on. I'll go here. Where should I go after this?
No, next line, 48.
All right. Then what would I do?
I think that's a print. Then I either have the something again. Yeah, with the press tab now. Then you lock it.
So,
No. So yeah, stay in it now. With the quotation there, you're gonna put
mm-hmm.
a comma.
All right.
You're gonna put I think a first name, something like so. Maybe.
All right. So,
And
is that your final answer?
I think I don't know no sir. I don't know.
All right. So I appreciate the effort. I really do appreciate the effort. However, what you're doing, let's see. All you're doing in this print statement, you're simply just printing first name and then you're accessing the value of first name, right? That's correct. Don't get me wrong. That is correct. However, to accept user input, I think someone raised their hand. Go ahead, Calvin. Please remember, if you
Yeah.
type in the chat, I won't be able to see it. So that's why I say open your mic. Well, go ahead,
After
Calvin.
that, the input, then the parentheses, the string, then open bracket
All
again,
right,
then
so
put
I'll use the input function.
yeah.
All right. for the string first name. So I say enter your first name, and then go here. You see that's what I should do?
Yeah, that might work.
Alright, so if I run this, I'll be able to. Alright, so that would be correct. That would be correct. So again, when you want to accept the value from the user, you have to specify that you are accepting an input by saying input. Well, tell the sense of feeling by saying input. Really? Well, if I can turn it, I should turn it off. By saying input parentheses, then you don't necessarily even need this. You can even let's not remove this. This one, that. We can still do it without it. However, you wouldn't want to display a blank console to your user, hence why you put some text in it. Alright, you don't want to display something blank to your user. So we're prompting them. This is the prompt. The input function specifies that or tells the interpreter, Python interpreter, that hey, we're asking the user for something. And then what you have within the parentheses is now going to say, hey, this is what we want to show to the user. This is our prompt to the user. And then whatever the user types, once they press enter after they type it, it accepts that value and then stores it within this variable called first name. And then down here, we're simply just printing out the value of first name. Cool? Is that understood? Is that understood?
Yes, sir. Yeah.
Alright.
Could that be shorter?
Could it what?
Be shorter. I have to use them in 2 separate lines.
The print statement.
Yeah. The input and the print statement. I'm asking if you could combine it to them or that will confuse the computer.
You want it. You're talking about having the print statement and the input statement in 2 different lines, correct?
Yeah, if you can have it in only one.
You want me to try having it in 1 line? I've never tried that before. Do you want me to try it?
Sir, you're the expert in us, sir. If you're not
By no means am I an expert. I said this is a learning experience. I'm here to learn from you guys as well. So let me try it. You see, I have first name, separate it by a what does happen? I have no idea what I just did. 1 second, let me see something. I did something. I don't know what I did. Yeah. I really don't know what I just did, but okay, let's move on. Do that, separate it by a comma, and oops, I'm assuming it would not work. We're getting a warning. Well, let's try. Yeah, it's definitely did not work. So, be safe to say, keep them on 2 separate lines, alright?
Okay, sir. Thank you.
Alright. So that's typically how we would accept a value from a user. Let's say, for example, we wanted to do some calculation. I know we haven't necessarily reached calculations yet, but I want to show you why we do typecasting, right? And I'm giving away hints as I go along. So let's say, for example, we want to have 2 numbers, accept 2 numbers from the user and add them together. We have a variable called num1 and we have a next variable called num2. Num1 is equal to input enter num1 and num2 is going to equal input. And let's say enter num2. And then we want to create another variable called results. And results will be equal to num1 plus num2. And we want to print the result. Is everyone following so far? So we're taking two variables, num1 and num2. We're accepting values from the user. We're storing it in a variable called result, and then we're printing the value. And we're just adding using the plus sign. We'll get to operators soon to show we can do different mathematical functions or operations with Python. So let's say we take the value of 5 and the value of 2 from the user. When you add 5 and 2 together, we get 7, correct?
Yes, sir.
All right. So if I add this 5 and this 2, I should get 7. Is that correct?
Well,
Yes.
sir, not in this case.
Why is that?
Sir, because right now both of the values are strings.
Why are they both strings right now?
Well, sir, because you didn't really use typecasting. Is that what you refer to?
Correct. So let me just run this. It gives 52. What it's actually doing is concatenating the two strings together, because you cannot add strings. They aren't numbers. You only add numbers, right? You can join two strings together. And when you join a string together, or two different strings together, two or more, that's typically called concatenation. So a rule of thumb to remember whenever you're accepting user input is that any input you accept is of type string. If I hover over it, you should see it pop up. So it's right here, reading a string from the standard input, right? How can we work around that? Two methods. First one, we can change them up from the result variable. We can typecast from either the input statement or the result variable. So here, let's say int. We go like so. Oops, what's happening? I can go here. Set this to be equal to an integer, and we do the same for this. So we set them to be equal. Oh, I keep scrolling into the sense. To be equal to an integer. So I run that. It should give 5 to 7, right, as the first way. Or the second way is by doing, I'll do it shortly, is doing this. We go up to our input statement and we cast before the input. So let's say, we'll say int, first parentheses, I will put our second one at the end. So we accept int. We're accepting an integer type. And we run this, it should, and we use the same two values, 5 and 2, it should give 7. So those are the two ways. You can either cast from where you're doing your operation or from the input statement. Typically I just cast from the input statement because I find it more convenient, because I won't forget to do it later on down here. So I just do it one time and done. So that's how that works. So yeah, whenever you accept value from a user, it's typically as a string, and then whenever you want to work around that, you would use type conversion. Now there's something that I want to make note of. What would happen if I set this value up here to a float and this value to an integer? Does anyone have any idea?
Well, sir, would the int be converted to a float since in memory the float is has larger space or something like that?
Essentially, but I don't like how you say it. Well, typical, you are correct, you are. But let's not say it's converted to a float per
Oh,
se.
sir, cast
Yeah,
type yes, sir.
because
Would it be explicitly cast or something like that, or
yeah.
implicitly? Or,
So what's happening is that the float value, as you said, would override the integer value. And there's a good reason for that. Because let's say you add 5.5 to 2, the result would be 7.5. 7.5 is of type float, not of type integer. So the floating point value would take precedence over the integer value. And that's why the value would be returned as type float. So to show you, 5.5 plus 2, we get 7.5. Everyone understood? Let's move on. I also want to show you guys what I meant by concatenation. So let's actually go all the way up here to some stuff that I prepared before. Um, yeah, let's do this. Oops, let's get back that. So let's say we have the name value and I set to an input, we're getting input from the user, telling them to enter a name. And then we want to print a message saying welcome. Let's say we print the name or a message plus the name. In this instance, we wouldn't be adding the message and name together. We're not adding them together like how we would add 5 and 2. What we're actually doing is joining them together, but we call that concatenating or concatenation of the strings. So if I run this, it will ask me to enter a name, and then our message is already predefined, so I'll then just print out message plus the name, and it should print message and then whatever the name is, because the message is being printed out first. So if I run this, it says welcome whatever the name is. Now typically whenever you're doing something like this, or whenever you're doing any form of concatenation, you want spaces to occur, unlike here. So how would you do that? Take a good look at this right here, right? And then look at the code that is written up here. Examine it for like 5 seconds or so,
You
and
put
then
a space after welcome and between the apostrophes.
right here,
Yeah.
right, so between welcome and the quotation. That is correct. And if it was the other way around, then you would put the space here. This is why I'm always leaving spaces, so it can know, it gives the interpreter instruction on where to accept the value from. So without that, then it would be null and void. So let me add it, put it, and then go back, and we now have the space. If we add more spaces, you would get all the space you want. And we see that happening right here. So always remember to be careful whenever you're working with user input as it relates to typecasting and concatenating. And yeah, that's pretty much it for now. we have a few mathematical operations that can be performed in Python here. I'm just show they will play a role later on more evidently, but for now these are just some of the basic ones you'll need to know. Addition is plus symbol, subtraction the minus symbol, multiplication with a star symbol, division the forward slash right where your question mark is, so that's control question it's question mark, not control question mark. So it's control question mark, not control question mark, just where the question mark symbol is here. And then the modulus operator, which tells us the remainder of something. And we can use modulus whenever we're working with, whenever we want to find if something is true or false. And this is also a hint for what's coming up next, so just pay attention. A quick example of modulus for those who may not understand. Let's say we have a equal to 10 and b equal to 3. Then we can have an c is equal to a mod b. A is 10, 3, b is 3. So a mod b, to print, let's print a, so let's print c. It should print 1 because 3 goes into 10 3 times and it leaves the remainder of 1. So if we print this out, c should be equal to 1. So if we run this, I still have this going on up here. So let's comment this out and rerun this. It prints out 1. Or let's just say this. So it's a mod b. So a mod b is 1. A mod b is 1, just like that. Kill this instance, kill that instance, kill that. Alright, so that's how that works. Again, the rest are pretty straightforward: addition, multiplication, subtraction, and division, and then modulus. Right. So I would have asked how to create a basic calculator that adds 2 numbers, but it's already here and I already showed you before, so I don't think there's a need to do that. However, in your own time you can practice, especially if you are just a beginner, you may not fully understand, then go ahead and practice. And remember, it's being recorded, so everything you want to know, you can go ahead and then rewatch the recording. So let me not go to list, as a matter of fact. Let's go to let's skip to this one before we do a list. So let's go to conditionals. So I think this is more important to learn first. So let's see. Let's see, for example, before we reach conditionals, let's say you want to check the equality of something, and these fall under operators in Python, right? Let's say you want to check the equality of something, and when I say the equality, I mean if something is actually equal to something else. And this is where we use the double equals or the equality operator. So earlier I showed you that a equal to 6 is saying whatever is saying that we have a variable called a, then we're storing the value of 6 in a. However, if we have a double equals b, that means whatever the value of a is equal to b, or we can check if the value of a is actually equal to whatever is stored in B. We do that using an if statement, but we'll be looking at that shortly. I'm just explaining the concept of the operators right now before we run into some practice or run into actually using if statements. And similar to checking equality, we can check if something is not equal by using the not equal operator, which is just an exclamation mark and then the equal sign. Then we have less than, which is self-explanatory. Less than or equal to. Greater than, then greater than or equal to. Then we have some logical operators such as the word and, which is reserved for Boolean logic, which we touched a bit on earlier when we were looking at data types, and the word or, again, reserved for Boolean logic. And is used to check if both conditions are true, and or is used to check if either conditions are true. So and is only true if both conditions are true, or is only true or is true if either conditions are true. So one could be true and one could be false. The operation would return true because one of the operations are true. Alright, is that confusing to anyone?
Go over it again for them.
Alright, what part exactly? All of it?
Yes.
As in from the very top up here?
No, just the and or and that also.
Alright, so let me... I think the best way to understand it is by actually showing you with the if statement. So don't worry, I'll get back to it shortly. But I'll get back to you shortly. When we're doing if statements, I'll show you exactly how they work. But for now, just know that and returns true only if both conditions are met, and or is true if one condition or more isn't. But I'll definitely get back to it. Let's go up here. We should have a hashtag. Alright. So here we use a plus operator to add two values together, which I mentioned earlier. In here we're doing a print statement. Then it's just as I said earlier, we have the arithmetic operators, which are plus, minus, multiply, divide, modulus, and exponential, which is saying something like 2 to the power, how we would write it on a pen and paper, 2 to the power of 3. That's all exponential does. Modulus, as I said, gives the remainder. Division, multiplication, minus, and subtraction and addition are pretty straightforward. Then we have the assignment operators, which we can use to assign values to variables, and we'll be looking at these in a bit more detail later on. So we have equal operator, which says x is equal to 5, or the value of 5 has been assigned to x. We have the plus equals operator, which in some sense is compounding the operation that we want to do. An example of it is saying x plus equals to 3. And what it means is that wherever we have x being set to a value, we'll be adding 3 to that x. So it's here. So x is equal to x plus 3. This and this is the same thing. However, this is the shorter way of writing it. So let's say, for example, x was equal to 9, right? Then we said x plus equals, see, we're checking some condition, we're doing something, right, using either a if statement or a loop or something of that sort. which we haven't discussed as yet, but we'll definitely discuss later on. We're doing all of that. And then we're simply saying this x here will now be 9, right? Because the value of x is 9. So you can look at this as saying 9 plus 3. So x plus equal 3 is simply saying 9 plus 3. Because whatever x is, we're taking it and then we're adding, we're putting back the value of x, and then we're simply adding 3 to that value. For a practical example, let me create a new file. Let's create a new file. Pi. Go here and print. Let's go ahead and print x. Go ahead and print x. Let's print x here as well. So print x here. This will be equal to 9. And this will be equal to that. If we run. That was up there from earlier. Yeah. So 9 and 12. Because all we're doing is saying, hey, whatever x is, which is 9, we're simply adding 3 to it, which is the same as also saying x equal to x plus 9. But it's just a shortened way or a shorthand way of writing over all of this. Is that confusing? Is it confusing to anyone?
Yes, sir. Can go over one more time, please?
All right, sure, no problem. What before I go over it, what part of it exactly is messing you up?
The very first one with the equal one. Just the one that alone.
Oh, the double equals?
Yeah.
Alright, so the double, alright, you know what? Alright, so I'd have to do that. We've been working with if statements. But why not? Someone was having problem with that, with the if statement and or earlier. So let me just do this. I think I had it. I think I had an example earlier in one of these files here. Okay, let me not use that example. Let's not do that. I'll just create something else. So let's go back here. Let's say, for example, all right, let's say I have A, right? A is equal to 18 and B is equal to 19. So if A double equals B colon print, what do I want to print? I want to print true. So if A double, so this is an if statement. This was what I wanted to get into, but I'm just going to show it from now. Since so many people seem to be a bit confused to it using the equality operator and or, right? So let me just get into it from now. So if this is saying if, and we use it by using the keyword if, then we pass in the variable, in this case, or what we want to evaluate. So we're passing the condition that we want to be checked. So notice the syntax. It's keyword, the condition, then the colon, then we indent. we indent. Typically in Python, you indent by 4 spaces. However, it doesn't matter if I go beyond that. But why? Right, let's keep everything clean at 4 spaces. And also, you typically want to keep everything at 4 spaces for when you're doing nested work. Again, I'll get into that soon. But to not get confused with indentation errors, we keep everything at nice, consistent at 4 spaces. So it's 1, 2, 3, 4. Right? Want to print true. So if A is equal to B, you want to print true. If I run this, it will not print true because A is not equal to B. This is not, nothing will happen. It cannot execute this. What I'm going to do, I'm going out of the if statement, out of the indentation or the scope of the if statement. It is why I didn't want to touch the statement as yet. But notice I have my 4 spaces right here. So anything contained within these 4 spaces are part of the if statement. It doesn't matter how long they want to go down to, right? I can have a million things as long as they are consistent with this level of indentation, then they are a part of said if statements, right? Oh, let's just delete that. Let's come outside of it now, and I print. Why is this thing keep asking? I want to print A is not equal to B. What will happen in a case like this, let me just separate it, is that if the if statement was true, the interpreter would go down into this block of code and then execute it. However, if not, it completely ignores everything that is scoped or inside of the if statement and then goes to the next line of code and then evaluate whatever is there and then execute that. No, because A is not equal to B. Remember, right now we're checking if A is equal to B, which we know not to be not true because A is 18 and B is 19. Right? It's not going to print true. It's going to ignore that, come down here and then print A is not equal to B. So let's run this. And it should give you A is not equal to B. If I had the not equals operator, if A not equal to B, print true, it will execute this block of code because A is not equal to B. So this is true, and because this is true, it will then execute whatever statement I have here. Bear in mind, it will still break out of this if statement and then come down here and then print this, because it will be finished with this execution and then move on to executing something else, which is down here, right? So to just ignore that from now, let's just comment this out and run it, and it should print true. So let's go here, and it prints true. Why? Because A is not equal to B. So you understand how that works with the double equals now?
Yes, sir. Thank you.
All right, cool. So someone said they had issues, and I'll be going to if statements a bit more in depth later on. When it comes down to learning how to use them, using them more efficiently, nesting them, and evaluating multiple conditions. But this is just a quick run through to understand how the double equals work. Right, so for the person who said they didn't quite understand the and or. Let's see. What should I do? Let's try. I should do. Okay, let's say, for example, let's have this be equal to 18, right? If A and B, if no, let's not look at that one. If A double equals 18 and B double equals 18. So we're checking if A is equal to 18 and if B is equal to 18, which is the appropriate way to do it. Don't say if A and B is equal to 18. Say if A is equal to 18 and B is equal to 18, then you execute something. In this case, it would print true because both these statements are correct. A is equal to 18 and B is equal to 18. It executes whatever we have here in this if statement. Let's say, for example, we have OR. So if either A is equal to 18 or B is equal to 18, then we want to print true. In this case, only one of them is equal to 18, which is A. But because only one condition is satisfied using the OR operator, it will still execute the program. So if I print this, it should print out true, which we can see here. However, let's change this back to and let's uncomment this because this won't run. Then we'll say A is not equal to 1. Both conditions were not. Yeah. So from this, it should print both conditions were not met. Why? Because this AND statement says both of these need to occur and be true. However, only one is true. Hence, it ignores whatever is in the body of the if statement and then goes on to execute the next piece of code down here. Understood? Anybody understood?
Yeah.
All right. Thank you for that. So, moving on. To get into it a bit more formally, let's just close this. Where was I at? Yeah, so equal, not equals. I think I was here. I think I should have been somewhere around here. Yeah. So that's essentially how that works. It's the same thing with the minus equals to saying x minus equals 3 is the same as x is equal to x minus 3. Star equal or multiply equal. We're just simply taking the value of x and then multiplying it to 3. Divide equal, or we can do mod equal or modulus equal to get the remainder. Then we have the comparison operators, which we looked on a bit a while ago. The double equals, the not equals. We can do greater than, less than, greater than or equal to, less than or equal to as well, which we'll look a bit more on. And then we have logical operators such as and, or not. Now, and as I said, works if both statements are true, or if one is true, and not simply does the opposite of what you want to return. So we have an why is this not showing? It should be, oh, I know why. This should not be right here. This should not be right here. So it's not, the screen isn't, I don't think, yeah, there it is. It's a bit harder to see by this. What it says, x is less than 5 and x is less than 10. So if we had x set to something like 4, then this will return true. We have x less than 5, x less than 4. And we had x set to, let's say, 3 or something like that, then it would obviously return true, even though both are true and we're using R. Still return true either way. If let's you just probably have to tamper with the values a bit, and then this simply returns the opposite of what is expected. So using back the 3 example, it would be true, but it would return false in the place of 3, in place of true. Understood? All right, move on. All right. So those those will be the main prerequisites that you would need to know before moving on to if statements. So with that being said, conditionals. Let's look at if statements now, and let me just get. I believe it was this one. I don't want to close this. Oh no, actually, let me do this. Let's close that. Let's close that, and let's open this. And we'll look at not, break, and continue shortly. But before that, let's do, where is it? It should be not prereqs, should be if dot md. Okay, great. So this is where we are at. So if statements. So an if statement is a decision statement in some sense. We can use it to evaluate different conditions on either a true or false basis. And we do that by essentially expressing Boolean operators, which I said earlier, which can either be true or false. So you can think of an if statement as an extension of a Boolean operator to some sense. However, it is so much more than that, because you can check an endless criteria of conditions or evaluate an endless criteria of conditions by doing all type of stuff with an if statement. So in this case, we say A is equal to 33 and B is equal to 200. If B is greater than A, we are going to print B greater than A. Because this condition is true, it will print B is greater than A. So if I remove, let's put this right here, let's keep this right there. Let's pre if, right. So let's go here. And if I do this, it will print B is greater than A. Because B is actually greater than A. However, if I change this to 1, nothing will happen. This block of code right here will not be executed. You will just print out nothing at all, see? Because there is nothing to specify, hey, if this isn't met, go and do something else. And we'll actually look at that shortly. That's when things get a bit more interesting. So the other example, A is equal to 200, B is equal to 33, C is equal to 500. If A is greater than B, A is greater than B, A is 200, so it is greater than B, and C is greater than A, C is greater than A, when we want to print both conditions are true. This will print both conditions are true because, well, both conditions are true. A is greater than B and C is also greater than A. The AND operator, logical operator, only works when both conditions are true. Because both conditions are true, it will print out or it will execute whatever statement has been specified from the body of the if statement. So if I run this, if you guys are hearing any noise in my background, I apologize for that. I really don't have any control over that right now. So if I run this, I have to define these. My bad. So if I go back here and print those, great. When I run that, it prints both conditions are true. So show it again for those who did not see it. Hopefully I'm not moving too fast. Time is against us, but I can extend if necessary. Yeah. And then we have the OR condition, which I'll just simply copy and paste over to my Python file. Go like so. A is equal to 200, B is equal to 33, C is equal to 500. If A is greater than B, or A is greater than C, which is false, because A is 200 and B is 500. C, is 500. A is not greater than C. The OR condition, however, will say that, hey, go ahead and execute whatever is in the body of the if statement because one of the conditions has been met. So we're just going to evaluate everything as being true. So we're saying at least one of the conditions is true. And if we run this, it will print at least one of the conditions is true. So that's typically how you would use an if statement in Python to make a decision. Now, I want to point out to you that you don't have to set the values as I did. For example, you could say service at 200, right? Let's say A equal int input enter a number, right? Let's do that. You could prompt the user for an input, and let's just use back 200 in this example. So we're like, hey, 200, and it says at least one of the conditions is true. So you don't have to say, oh, we want that. No, you don't have to implicitly define or initialize a value. You can ask for input. You can use each method or each concept that you have learned to combine them together to do something amazing. You don't have to do them piece by piece, because that's not how programming in some sense is kind of like mathematics. However, I believe the beauty of programming is that there are less things to be learned, and as such, it's a bit easier to remember and do things. Whereas with math, if you don't know how to do one thing, then that might mess up everything else for you in the future. Now, that can be true with programming, but it may not always be true. An example of it may not always being true is what I did earlier, where I declared a value, or I defined a value that was explicit by me. And then an example of where it may not be true is where I ask the user for an input. So let's say you don't know how to ask the user for an input, then you might be stuck on doing something, right? But if you know, you know. So you can combine the different methods or the different give me a second. So you can combine the different methods or the different things that you have learned so far to piece them together to create something that typically you wouldn't be able to create. All right. So with that being said, before I even move on, let's see what's next. What's next on the list? else statements. All right. So before I move on to that, is there anyone that is lost? Any concerns you have about what I just did with the if statements? Okay, no. I'll take it as if we're all up to speed. All right, cool. So, so before we've been evaluating if an if condition is true, right? Then we do something, and then we have, if it isn't true, we want to do something else. Now, what we did of saying, hey, we scope something outside of the if statement by using a print statement here is okay. However, there is a better way of doing it, and we do it by using what is called an else statement. So an else statement checks if our initial condition fails, and then it executes the body of code proposed within it. So let's say we have the following. A is equal to 200 and B is equal to 33. If B is greater than A, which is false because B is 33 and A is 200, we want to print B is greater than A. Because that is not true, or because it is false, and the reason why I'm emphasizing true or false is because earlier I said you can think of if statements as an extension of Boolean operators, which can either be true or false. I'm just emphasizing that to kind of drive the concept. So I want to say if B is greater than A, which is false, then we want to say execute this down here, because what happens is that because this condition, because it's on the wrong place, because this condition is false, Python will ignore all of this and then go on to the else condition and then execute what is in the else condition. So the else condition will always be executed by default if the if condition is true. So even if I didn't have a string here, for example, let's say I was printing out A plus B, right? It would then print out A plus B. This else condition will always run once this if condition, is false. To prove that, let me just copy this, go over here, comment that out, run this, and it will print 233. Why? Because the if condition is false, hence it runs into the else block. Now, when writing the else condition, let me just walk it through it from scratch. So let me do my tilde pi. And for those of you who may not know, I'm actually writing the notes in a language called Markdown. It's just like a text language that you can embed code into. Notice I can't run it. I don't have the option to run it, as in when I do the Python file that ends with the .py to specify that it's a Python file. But I can just simply embed code for explanation. Right? So let's say I have if, right, with the colon at the end. Then we do print statement. We come outside of the indentation from the if statement, doing a backspace. As a matter of fact, I'm going to show you, let's not do it here. I'm going to show you in an actual code file. So we say if, let's keep these two. So if A plus B is equal to 233 colon, is equal to 234 colon, enter. We have our 4 levels of indentation, right? Or 4 lines of indentation. Let's delete that, come here and say A is 234. If we go back here and write else, that will be wrong because it's still in the scope of the if statement. So what we do, we come outside of the scope of the if statement and say else colon, go down and say print 233 is the correct value, and we end it like so. So if A plus B is equal to 234, which is false, this line will be ignored. Then this will be executed by default and print out whatever or do whatever operation we have in the else block of. So if I run this, it should print 233 is the correct value. Let's run it. 233 is the correct value. If I change this, let's say that left correct, and change this to 233, then this else block here will be ignored because this if condition is not true. So let's around to true and see this is executed and this is ignored. So if we run this, it will print correct. So it prints correct and it ignores what is down below because the first condition has been successfully satisfied. Has that been understood? Hello?
Yes, sir.
All right, great. So everyone by now should have a basic understanding of working with if and else statements. So before we go, because time is really among us, well, not among us, but against us, what I'll do is just have everyone, let's just run through a quick exercise of using if and else statements, and then end it here for today or tonight, and then hopefully next Saturday, if we don't have any test because test time is approaching, we can run through nesting if statements, looking at elif statements, going on to loops, for loops, while loops, looking at lists, looking at tuples, and possibly maybe OOP and pip and using Python. Just learn a bunch of other stuff so that you can have good enough knowledge of Python to do some complex stuff on your own. Maybe look at a few methods, a few inbuilt Python methods. So before we do all of that, before we close, let's just run through a quick example or a quick exercise using if statements. So we want to say, let's think about it for a bit. Let's think for a bit. So So let's say, for example, we wanted to check if an operator entered by the user is equal to something, then we'd perform a specific calculation. Let's not do that. Let's save that one for a different time. Let's check if a number A, 100. Now let's check if a number is even. Let's do that. So if a number is even, we'll print even. If it's odd, we'll print odd. Can anyone walk through, and don't be afraid to get it wrong. Don't be afraid to get it wrong. It's a learning moment. Let's walk through it and then we can end the meet and I'll inform you guys when again. So let's say we have a number, two numbers being entered by the user, and we want, let's ask the user to enter a number, and then we want to check if the number entered by the user is an even number or an odd number. How would we approach that problem?
Well, sir, first we'd ask the user to enter an integer.
All right, so we're calling it num1. That's equal to int, right? Input, because we're getting user input, and we're telling them to enter an integer. All right, that's correct. Now, what would be the second step?
Then we'd include a if statement.
All right, so you're on the correct path. So if what are we evaluating?
Well, sir, if num1, and then we'd have to use the modulus operator.
Why would we use the modulus operator?
To determine if the number is an even number. So like for instance, num1 modulus 2. So if the result of that is like anything besides 0, then that would mean it's an odd number. So if it is 0, then that means it's an even number, because that means that there's no remainder.
So what you're saying is I should say if num1 mod 2.
Yes, sir. Double equal sign.
Double equals 0, colon, all right. Then
yes, sir, you would say print, and then you would have in quotations, well, parentheses, then in quotations. Yes, something, yeah, it is even number. Yeah.
All right. Then and if then it's not have, even.
Yes, sir, then you would have else in another line.
Right here?
Oh, no, sir. At the
starting.
Yes, sir, yes, sir. Else colon. You would have in another line print in quotations, then in parentheses, then quotations. Num1 is odd.
All right. So we should run this, and we enter. Oh, this is and. This should be enter an integer. Let's enter an integer. Let's enter 200. It says num1 is even. Now, the reason why this works is because num1 mod 2, which is saying that when we take num1 and we divide it, well, not divide it by 2, but when we put 2 into num1, if the remainder is 0, then we want to say that, okay, execute this statement. So because 2 can go into 200, leaving no remainder or 0 remainder, hence double equals 0, we're checking for equality. Hence, this gets printed out. And to take it a step further, we could even say num1 comma, um, comma is even. So it would print out num1, which is 200, is even. So we entered 200 and it prints out 200 is even. If we run this again and we enter 200 or 2001, let's do 201 instead. It says the number is odd because when 2 goes into 201, it does not leave a remainder of 0, but a remainder of 1. Hence, this else block of code is then executed. Alright? So, I trust that it has been a productive session. The video will be posted along with the notes. I'll send everything in the WhatsApp group. I'll send an update in the WhatsApp group rather when everything has been done. So just give me some time to do all of that and enjoy the rest of your night. And I'll provide updates for when we'll meet again to finish our syllabus in Python before we can move on to learning artificial intelligence. So until then, everyone, take care.
Yes, sir.
Yes, sir.